Precalculus second 6 weeks common assessment. This is for fall 2016. There are 22 problems total. Problem 1, which of the following divisions will produce a remainder of 13 over x minus 1? There are different ways you can do this. You can go ahead and work out polynomial long division, synthetic division, and I'll just go ahead and do a synthetic division process on answer choice B. So we go ahead and put our little synthetic division bracket here. We can put 1 here, and then 1, 1, 3, and 0x squared plus 5 minus 10. So if we just work this out, we get 1 times 1 is 1, 4, 1 times 4 is 4, 0 plus 4 is 4, 1 times 4 is 4, 5 plus 4 is 9, 1 times 9 is 9, negative 10 plus 9 is negative 1. So that is not a remainder of 13. And we use something we call the remainder theorem, and that's going to be f of k is going to be our remainder. For divisor of x minus k. And so for answer choice C, we can plug in f of 1 equals 2 times 1 cubed minus 5 times 1 plus 16. And that's going to equal 2 minus 5 plus 16, which equals negative 3 plus 16, which equals 13. So that's going to be our remainder. And to just synthetic division, I think that a lot of people have to do synthetic division. If we have 1 here, 2, 0, negative 5, 16, we have 0 because 0x squared. We have 2, 1 times 2 is 2, 0 plus 2 is 2, 1 times 2 is 2, negative 5 plus 2 times 2 is going to be 10. Times 2. That somehow doesn't work out here. It's going to be negative 3, excuse me. Multiplying, so that'll be negative 3. 1 times negative 3, negative 3, 13. Okay, the remainder of 13. Correct answer choice C. Next problem, what are solutions to the equation shown below? Well, we can use zero factor theorem. We set each of these factors equal to 0. So we have x equals 0. Our next factor is going to be x minus 3 is equal to 0. And our last factor here, we have x plus 5 equals 0. So we have x equals 0. We have x equals, if we solve for x equals 3, and x equals negative 5. So negative 5, 0, and 3 are the correct zeros or solutions for this. And if we graph this function, we could graph this as f of x in our calculator, x times quantity x minus 3 squared times quantity x plus 5, we would see the graph of the function touch the x-axis at -5, 0, and 3. Next, quartic function x to the 4th plus 5x cubed minus 8x squared minus 48x is 4 real zeros, which 0 has a multiplicity of 2. Now for that, if we go to our calculator, let's see, I don't think I preloaded this one. So I'm going to go to Control I, add graph. We have for this one x to the 4th. I tried to preload most of these, but I just omitted this guy here. Plus 5x cubed minus 8x squared minus 48x, and we graph this function. This is what we get. Now, multiplicity of 2 would be where the graph function touches the x-axis but does not go through. So that looks like that occurs at x equals -1, -2, -3, -4. And I don't know of a really simple way to do this without graphing, because another way to do that would be more advanced factoring. So our correct answer for this will be D, x equals -4. Again, even number multiplicity will touch the x-axis but bounce off. Next, the table below shows the number of patent applications in certain years, starting 1980 and so forth. That 0 stand for 1980, 10, x equals 10 for 1990, and so forth. What I did is I preloaded this function. I went to listed spreadsheets and I entered this information. So next I'm going to go to Control I and get data and statistics. And here we have all the points available. Somehow it doesn't look exactly right. Let's see what we have here. Tab X. Oh, I wonder where this came from. Tab Y. Actually, it does. That's going to be the years on the x-axis and number of patent applications along the y-axis. It says using a quadratic regression. For quadratic regression, we go to Menu, we go to Analyze, and we go to 6, Regression, and then 4, Show Quadratic. And we have our function here that models as a quadratic regression. And we're going to trace along this curve, and do that. We go to Menu, Analyze, and then Option A, Graph Trace. And then we can just go to the right, and we can see it at the right, 286,294. When we get to closest to 450,000, let me just keep on going up. So here we are between 446,000 and 456. So this is kind of as close we're going to get. It looks like we're at 26. Well, what that's going to be is 26. We have 1980, which was year 0, plus 26 is going to be equal to the year 2006. So our correct answer is C, 2006. Next, which equation will translate the function drawn below to a new function that will have x equals negative 2 as a vertical asymptote. What we have is, if we take this function d, we have a discontinuity at x equals, well, let's rewrite. I'm going to write this as x plus 2 cannot equal 0. We can't divide by 0, so x cannot equal negative 2. And so if we go to take if we graph this, move over left, it'll look like this. Answer choice D. It so happens that answer choice B will also give us a vertical asymptote, but not a translated over function like answer choice D does. So D is our correct answer for 5. 6. The function g of x graphed below is a cubic function based on a graph which the following statements is true. The fundamental theorem of algebra said that the number of zeros, real and non-real, is equal to the degree of a polynomial function. And we realize that we have to have a real zero is crossing the x-axis. And D is patently false because you can't have, with odd polynomial functions, no real zeros, because you have to cross the x-axis. And C, g of x has 3 real zeros. Well, 3 real zeros is going to look like this for a cubic function, right? So it's not that. Has 2 real zeros and 1 non-real zero. Well, if you go like that and have 2 real zeros, like this and like this, there's no other way to get back up through there. So A is our only possible right answer, and what that's going to look like is exactly what this cubic function looks like here. 1 real zero, 2 non-real zeros. Next, 7. The function fx equals 2x cubed minus 5x plus 7 over 4x cubed plus 6x minus 1 has what horizontal asymptotic behavior? And I pre-loaded this function here, and what I did, let's get to, here it is, right here. This is the preloading. So I press enter, and this is what the function looks like. Now, horizontal asymptotic behavior is the limit as x approaches infinity or negative infinity. So what we need to do is get a very large number. As we go x toward infinity, we're going to approach the value of our horizontal asymptote. So we can do this a number of ways. If we go to Control T, we can just scroll and see what we get close to. Now, I hope you can see that here we have 0.498, okay? And what number is being approached? 0.499. As we go on, we're going to get closer and closer to 0.5. 0.5 is very close to which fraction? 1/2. So D is going to be our correct answer. If we look at it another way, our highest powers here are 3. So our answer to what our horizontal asymptote is going to be, if we simplify 2x cubed over 4x cubed, and we don't write these other things because as we get closer to infinity, the lower power stuff doesn't matter. And so the x cubed over x cubed cancel each other, and we're left with a 2 over 4, which simplifies to 1/2. So that would be an analytical way of looking at problem 7. 8. For the following division problem, what would be the proper synthetic division setup? Well, again, we have our 0 as 3. We say x minus 3. X minus 3 is equal to 0. We're going to have x equals 3. So 3 is going to go on the outside here. That's going to disqualify, I think, answer choice C. And what else? Answer choice D. And then the numbers here, we have 1x cubed, and, very important, 0x squared, and 2x and minus 6. So our correct answer is going to be B. Next, table shows the braking distance in feet of several speeds in miles per hour for a specific car in a day. So this is one of these functions that I already placed in here, and we'll go to here. It is. That's answer choice A. We enter that. This is what we see. If we go to our table view, and what we have here in our answer choice, we have every speed 10, 20, 30, 40, 50, 60. So we can scroll and get these numbers. But if we go to menu, table, we can edit table settings 5 and table start at 0 and go up table step every 10 units. So we tab down here, and so we get 0, 4.2, 16.8, 37.8. Okay, let's look at our answer choices here. 0, 4.2, 60, 16.7, 37.6, 66.9. We can keep on going here. 0.9. 104.5, 151, 206, 151, 206. So quite close. And so our correct answer is going to be A. If you try these others, they can be way off. Problem number 10, which function shown below is equivalent to f(x) equals x squared minus 5x plus 3? Again, I preload this in the calculator. And this is it right here. So this is what our function looks like. And that's our original function. And we're going to try to see which one is going to be the version of the in the vertex form. So if we go to Control I, add graph, I'm going to enter answer choice A, and this is answer choice A sitting right here. Quantity x minus 5 over 2 squared. Quantity x minus 5 over 2 squared. And then we have that minus 13 over 4. And we graph, we see the same thing we saw earlier. So that's an exact match. So let's go back one here. See, that's the same thing graphed here. This black one and this red one, same thing. So our correct answer choice is A, right there. 11. Which of the following functions has zeros of -1, 1, 3, and 4? So for that, for our zeros, for this to work out, for our factored form, this 0 of minus 1, it would be like x equals negative 1. If we solve that for 0, we're going to have x plus 1 equals 0. So x plus 1 is going to have to be one of our factors. And we're going to also have, if we have 0 of 1, x equals 1, then we're going to have x minus 1 equals 0. So one of our factors is going to have to be x minus 1. And similarly, our other zeros are going to have to be, our other factors are going to be x minus 3 and x minus 4. So where do we see all those? Well, if we look at answer choice A, that looks like we have x minus 4, x minus 3, x minus 1, x plus 1. A is going to be our correct answer. And you could graph these functions and see where they touch the x-axis too. 12. Which of the following rational functions has vertical asymptote of x equals 3? Well, it's going to be this answer choice A, because we have this x minus 3. We're going to have a vertical asymptote at x equals 3, and then we have one side of the curve like this, another side like this. So that's what it's going to look like. It should be very easy to graph these. Next, 13. Each of the following rational functions has two discontinuities. Which one has a removable discontinuity? I'm going to pick a wrong answer first and then the correct answer. We're going to look at answer choice B, which is not a correct answer, just to see what it looks like. And so if we go to Control I, add graph. Okay, this is answer choice B. We enter that. We don't see a whole lot. We see some kind of asymptotic behavior up here. And to really take a better look at it, we're going to go to our menu, and we're going to change our window setting. And I'm not sure exactly what's going to do the job for us, but I'm going to change this Y maximum. Instead of 6.6, I'm going to make it 50. So you see, I hope, better what's going on. And we see I still am missing something here. Can I go up yet higher? Yeah, let's do that. 4, window settings. Let's go up to 500. Okay, what we have is we have vertical asymptotes at x equals 3 and at x equals 5. So, and then if we go to our table view, Control T, we will see undefined. I guess it's below we see that. Let's go look at that. Control, oh, menu. I can't go to that. Control. Let's go to Control I, add graphs. Look at that thing again. I was going up to see the exceptions when you go down, rather. So let's go to menu, window zoom, window settings. I'm going to go tab down here to Y minimum. I'll put down -100. I think we should see, I hope, something better now. Yeah, so we see a vertical asymptote at x equals -3 and an x equals 5. So two discontinuities is what we're seeing here. So that's an example of a wrong answer. Now for the right answer, we're going to look at answer choice C. So we go back to our calculator, Control I, add graph. And here's answer choice C. We have a discontinuity at x equals -3, which we do not see. We see this vertical asymptote at x equals 2, and to get a little bit better look at that x equals 2 vertical asymptote, we go to window zoom, Windows settings. We're going to change the Y aspect. We're going to go from like negative 50 to 50. And there we see our vertical asymptote at x equals 2, but nothing at x equals negative 3. But if we go to Control T, we will see we are undefined. That's a vertical asymptote at x equals 2, but at x equals negative 3, we have a removable discontinuity, and the graph of a removable discontinuity we're not going to see when graphed in the calculator. So our correct answer is going to indeed be C. Next, problem 14. Which correctly describes the transformation of the graph f of x to g of x? And we have f of x and then g of x, and there's a slight difference. We go to our calculator. I go to add graph, and we go up to this function here, 3 to the x over 2, and graph that. This is what we look like, an exponential function. And then if we go to tab again, it's going to let me put another it's going to let me put another function there. Yes, it is. So we're going to put 3 to the power of, this time negative x over 2. And I'm hoping to graph them on the same plane here. So you see we have a reflection. This yellow one and black one are reflected about the y-axis. So for this one, our correct answer is going to be a reflection across the y-axis. That's answer choice B. Next, 15. Use the graph the polynomial function below, which is not a factor of x to the fifth plus x to the fourth minus 3x cubed minus 3x squared minus 4x minus 4. And so we have our zeros are going to be, just looking at them, we have x equals negative 2. We have x equals negative 1. We have another 0 here at x equals 2. And so our factors are going to be, if we solve one of these for 0, so if we add, we're going to have, add 2, we're going to have x plus 2 is equal to 0. So that's going to be one of our factors. We add 1, we have x plus 1 equals 0. That's another of our factors. And finally, if we subtract 2, we're going to have x minus 2 equals 0. So these are 3 factors that we see up here. And which one do we not see? We do not see the x minus 1 factor, which is related to 0 of 1. So C is our correct answer. 16. How many discontinuities is the function f of x equals 2x squared plus 9x plus 4 over 2x plus 8 half? Well, to find our discontinuities, if we set our denominator equal to 0, I'm going to set it not equal to 0 because it cannot equal 0. And if we subtract 8, we have 2x is not equal to negative 8. Dividing by 2, we have x is not equal to negative 4. So that's going to be one discontinuity as far as I can tell. And if when you graph it, you will just see an undefined on the table view. And I don't think this, I think this is a vertical asymptote too, because I don't think this is a removable discontinuity either. But either way, it's one discontinuity to be found. Usually when you have a variable in the denominator, an unknown variable in the denominator, that's going to be evidence of a discontinuity. There's an exception to that, of course. But that's our answer for 16. 17. Which of the following graphs matches the transformation of the rational function? And it's basically putting this function in here, and when you do that, and you get answer choice C. I haven't preloaded that. That's just one thing. You're just going to have to enter this and the function and see which one is the best match, and that's going to be answer choice C. 18. Which of the following functions matches the graph below? and you can try all these functions. I'm going to enter the correct answer, which I believe is B. And so you go to your calculator, Control I, and graph, and there. I don't have it here. Yeah, I don't have it, so let me go ahead and put it in here. We have, I thought I entered that before, but we have 2/3 x to the power of 6. So we'll go in here and put in 2/3 x to the power of 6, and this is what we have. Very flattened at the bottom, very much like the image here. This is going to be answer choice B. 19. Which of the following function represents the transformation of the rational parent function such the horizontal asymptote has been moved up 3, the vertical asymptote has been moved left 3, and the function has been reflected? Well, the vertical asymptote moved the left 3 is going to be x plus 2. So these ones here where you have x minus 2, I don't think they're very good candidates. And then, let's see, what it moved up 3. Both of these appear to be moved up 3, answer choice C and D. But reflected, and it says reflected, it's going to be reflected about the x-axis or reflected upside down. C is going to be your correct answer for 19. 20. A negative polynomial function of degree 3 has 3 distinct zeros of x equals -1, x equals 2, and x equals 4. The domain of f of x is all real numbers. Over what interval is the value function greater than 0? Well, for this, we can do this one of different ways. One way we could do is we could say, okay, we have x equals -1. There's x equals -1. X equals 1, 2, 3, 4. So we have 3 distinct zeros. X equals -1, at x equals 2, and at x equals 4. It says the degree 3 has 3 distinct zeros, and it says negative. So for negative, we're going to have each zero, and for 3 distinct zeros, we're going to have each zero with a multiplicity of 1. So we're going to come, a negative odd function is going to start from the upper left and go down, cross the x-axis, and that's going to come up at x equals 2, cross the x-axis, come up here, go down through x equals 4, and resume its march toward -infinity. So we're looking for greater than 0. So here we have above the x-axis and also between 2 and 4. So between -infinity to -1 is where we're going to have a above 0, and also between 2 and 4. So A is our correct answer. Another thing you can do is you can just recreate this. You could say, okay, let's just go ahead and make this, we'll just say f of x equals, you have a 0 of -1. So you have x equals -1. So our factor is going to be x plus 1 equals 0. So you're going to have quantity x plus 1, and your other factors are going to be x minus 2, and then x minus 4. And then since we have it's negative, we can just put a negative sign out front. If we graph this very function that I just put in red, you're going to see this kind of shape and see where the function is greater than 0. That would be from -infinity to x equals 1, in between x equals 2, x equals -1, between -infinity and -1, and between x equals 2 and x equals 4. Next, we're getting to the free response section here. What is the remainder when f of x equals x cubed minus 4x plus 5 is divided by x plus 3? Well, what we're going to have for that is, if we go ahead and set this up. If we have our 0 is going to be at -3, and then we're going to have 1 x cubed, 0x squared, -4x plus 5. And so if we bring down the 1, we get 1, -3 times 1 is -3, 0 plus -3 is -3, -3 times -3 is 9, -4 plus 9 is 5. We have -3 times 5 is -15. 5 plus -15 is -10. So our remainder is going to be -10. So negative, a lot of people get this one right that I saw. So -1, 0 is what this thing would look like. And you can put the 10 over at the far right. It really doesn't matter. Another thing you do is use the remainder theorem. And we can say, remember we had that x minus k, right? Well, in this case, k is going to be equal to -2. So our answer would be if we put in f of, oh, excuse me, I said -2, I meant to say -3. If we plug in -3 for this, we're going to get -3 cubed minus 4 times -3 plus 5. So we're going to get -27, and -4 times that's going to be plus 12 plus 5. So we're going to get -27 plus 17, which equals again -10. Confirmation. Our last problem is this one. The polynomial function g of x below has 4 real zeros with differing multiplicities. What is the value of the zero that has a multiplicity of 3? Well, we have this x equals 0. That's a multiplicity equal to 1, right? Because we just have 1x. This x equals 5. That has a multiplicity equal to 2 because we have x squared. This next one, x equals -1, has a multiplicity equal to 1. And lastly, this one here, x equals 2, has a multiplicity of 3. And so our answer is going to be this 2. So if we just put in 2 anywhere here, we can put a plus if we want to, but we don't have to. The thing assumes plus. So anyway, that's the test. It was a good test. A lot of people did really well on it. And again, as always, I say to you, thanks for viewing.